Okay, here we go. All right. So what we're going to talk to you about is hybridizing the carbon atom. It's talking about how carbon bonds to other atoms and what that does to its orbitals. So it's the orbitals for its electrons. Okay, so we're going to talk about carbon. We're going to talk about hybridizing the carbon atom. So there are several different ways to do this. And before we can start talking about hybridizing the carbon atom, we need to know that carbon wants to make 4 bonds every time. So that helps us. Let's take a look. Let me draw a molecule. And first of all, for the people at home, this is in a video that's on your assignment. When you go to your Google Doc, at the top of that Google Doc, there's a link, and it'll literally show you exactly what I'm showing you right now. Let's talk about propane, C3H8. We're going to start out with that bad boy. Everybody ready? Carbon, carbon, carbon. It's got to be the central. We're going to have 8 H's around this bad boy. Okay. This is the Lewis structure for propane. Propane is called C3H8. Now, how many bonds will hold these guys together? We'll see, this one's got 1, 2, 3, so it's going to need a 4th. That one now has 1, 2, 3. They're going to have to be single bonded. All right. So first thing we do is we label all of the bonds as sigma or pi. So we're going to be talking about this carbon atom right here. Okay? This first little problem we're going to be doing is about this carbon atom right here. So we're going to label all the bonds around it, sigma, 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 boom. That has 4 sigma bonds. A sigma bond is an sp hybridized orbital. That's what a sigma bond is. The initial bond, or the sigma bonds, are sp hybridized orbitals. So now I'm going to erase this, so I have some room. All right. That carbon in the middle of this molecule that we were just studying had 4 sigma bonds. Now the first thing I'm going to draw for you is the regular electron level diagram for carbon in its ground state. It would normally be 1s2, 2s2, 2p2. That's a regular old carbon that's not bonded to anything else. But now we're going to draw this carbon that was in the middle of that propane molecule that has 4 hybrid bonds. So our 1s sublevel does not change ever, okay? But this carbon has 4 hybrid bonds. The 4 sigma bonds are sp hybridized. They're a combination between s and p. So we're going to write sp here, and we're going to say 1, 2, 3, 4 there. 1, 2, 3, 4. So there's nothing else to draw. We've done all 1, 2, 3, 4, 5, 6. We've drawn all of carbon's electrons, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? Carbon is number 6 on the periodic table. So we're done. Now, this looks like it would be called sp4 hybridized, but it's called sp3 because you think of this first one being the s that was hybridized, and then 3 of the p orbitals were sucked into that hybrid bond. So it's called sp3. The first s is from the 2s, and then these p's were from the 2p, okay? So sp3 hybridized is what that's called. Let's draw another one. Okay, what if we had, let's see, he already did hydrocyanic acid. How about FCP, all right? There's our Lewis structure. Let's see, we'd need 2 more dots for that P, and this F would need 1, 2, 3, 4, 5, 6. and that carbon in the middle would end up having 1, 2, 3, 4. It's done. Does everybody see what I'm getting at? So this carbon's got its 4 bonds. All right, now let's take a look here, okay? This one would be called sigma. This one would be called sigma. And then the other 2 here would be pi and pi. Right? So remember the sigma bonds, there's 2 sigma bonds, so there's going to be 2 sp orbitals. So we're going to start here at the bottom. 1s, up, down, that's always the same. And then there's going to be 2 sp orbitals. Sp, we're going to have 2 dashes there. And then there's 2 pi's. So that means there's 2 in the 2p left over. The pi orbitals are just leftover p orbitals that haven't been affected. That's what the pi's are. So this one right here, where this carbon has a triple bond on one side and a single bond on the other, that would be called sp1 hybridized, because one of your p's was drawn down in here into this warped shape. So we'd call that one the S and that one the P. sp1 hybridized. All right, let's try another one. Remember, the biggest part about this is that what you have here in the middle, the sp, that's how many sigmas there are. If you can just remember that one part, you'll probably get it right. However many pi's there are, that's how many 2p's are going to be left. That's it. Does that make sense? I'll give you one more. What if we had C2H4? Let's see here. C2H4. So give me a C. Carbon's obviously going to be our central atom. We'll spread these 4 H's around like that. And each carbon has 2, so boop, boop, we're going to need a double bond right there. Let's label these bonds really quickly, okay? We're labeling them. Sigma, 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 pi. So there are 3 sigmas. There are 3 sigma bonds. So there's going to be 3 sp arrows, right? So the bottom, again, is always the same. 1s has not changed. Then we'll say sp right here for our hybridized orbitals. And there's 1, 2, 3 of those. Beep, boop, boop. Up, up, up. There's 1 leftover pi orbital. So that pi is a leftover p orbital. Boom. What would this be called? Anybody in here know? It would be called sp what? sp2. S and then 2 p orbitals. sp2 hybridized. So that carbon is sp2 hybridized. That's the quickest lesson I can make it. If you are at home and I went too fast or you don't understand, the video link at the top of the document, just click on it and it's a guy explaining it as good or better than I just did.